Yeah, there was a whole page. Do what? The coupling, yes. Because I put in a new coupling slide. So the ATP coupling one that you have, X that one out. All of these are going to take place. Okay. Okay, so ATP, ADP. For everything that cell has to do, every single chemical reaction, whether breaking something down, building something up, that cell, the energy for it is ATP. So at the cellular level, it is the job for the cell to be able to get the minerals, get the nutrients, get the foodstuffs, whatever the case might be, and use those, make ATP, use that ATP to provide energy to whatever chemical reactions need to occur, and then start this whole process over again. So, in thinking about, all right, catabolism, anabolism, okay? For anabolism, what is that doing to a molecule? Is it building bonds or breaking bonds? And then if we think about our catabolism, what are we doing? So now, if we look at this picture, okay, if we think about foodstuffs that we have taken in, all right, those foodstuffs, unless it is a single glucose molecule, all right, the body has got to break those foodstuffs down. So this means we have to take those larger molecules of a foodstuff, for example, let's say a protein, a fat, any type of sugar other than glucose, okay? We have to break that, and then we have to use it to make ATP. So we have now taken something, broken it down, used the parts to make ATP. Does that make sense? Okay. Now once we have ATP, ATP can provide that energy for the cell to do something. Okay. For example, it could be a protein, the sodium-potassium pump in the membrane. ATP would have to give up a P and become ADP. So now we have provided energy to that protein. And the process pretty much just starts over. Okay? They say that in some cases, ATP is renewable, because that phosphate that got used can actually go back to an ADP molecule. But the problem is, we are using the energy so quickly. The cells of the body the number that we have, the activities they have to carry out, the energy consumed every day is more than I could probably even think about, okay? But now, the way that we are looking at energy use, we are looking at it using a glucose molecule. The reason we're using the glucose molecule, it is the only molecule that goes through glycolysis. Okay? Hence the term glyco, all right, sugar. Let's take a peek at that. The glucose molecule right? The formula okay? Something that they mentioned in the video, not sure if you picked up on it. Did you pick up on how they stressed that carbon to hydrogen bonds contain a lot of energy? Did you pick up on that? Okay. Now let's think about that for a second. All right. We've talked about elements. We've talked about the ions. Okay. We've talked about molecules forming. If you remember, organic chemistry is carbon-based. All right, so everybody remember that, okay? And do you remember when I showed the carbon molecule, how we take that information from the periodic table? And that lets us know a little bit how its structure is and how many electrons are in the outer shell, meaning how reactive it is. So if you remember, carbon is number 6 on the periodic table. So that tells me in that first outer shell, how many electrons do I have? 2. Because the first shell can hold up to 2 electrons. But I have how many left over? 4. So that second shell can hold up to how many? 8. It's called the octet rule, okay? So that tells me those remaining 4 electrons are out here. Do you happen to remember what number hydrogen was on the periodic table, Kevin? 1. So that tells me I've got 1 electron in that outer shell of hydrogen. Therefore, carbon readily combines with hydrogen. So it has 4 spots, so to speak, available. So it would readily form with 4 hydrogens. Okay? Now, take a peek. I have 6 carbons. 1, 2, 3, 4, 5, 6. Okay? 12 hydrogens, which would be arranged. Oxygens would be arranged to make this the glucose molecule. Because it has that many carbon to hydrogen bonds, This is why glucose is considered high energy, okay? Because it contains quite a few carbon to hydrogen bonds. In table sugar, the one that is my favorite, that one is a glucose and a fructose together. And have you ever seen some of the experiments where they take like a spoon of table sugar and they can hold it like over like with a lighter or one of the little gas, help me out here, Kevin, because you're chemistry. I know
it's Bunsen burner.
The Bunsen burner, okay. Had it in my hand, I just couldn't get it out, okay. And they hold it over it, and that sugar actually burns. The reason for that, the number of carbon to hydrogen bonds in it provide that much energy. Okay, so carbon to hydrogen bonds, they have a ton of energy. And think about this, our foodstuffs, sugars, proteins, fats, the basis of their makeup is carbon to hydrogen bonds, giving energy, which is pretty cool, okay? So, the only one, however, that can give us some energy without even having to encounter the mitochondria is the glucose molecule. So, we're going to look at what happens with the steps of making this ATP. When we look at that process in the cell, where we know we've got our nucleus, all right, got our endoplasmic reticulum, little Golgi apparatus, blah, blah, blah. But then within that cell, we're going to find those little kidney-shaped organelles that are our mitochondria, okay? And their structure is a little bit unique, all right? And just a reminder, they do have a double membrane, just like the other organelles in the cell. So let's think about this, all right? So I'm going to ask the question again. How many of you had breakfast this morning? Good job. I'm seeing more hands today, okay? Did any of you consume anything that would be considered a sugar? Me too, okay? Love those little Jimmy Dean breakfast balls, okay, with like the little potatoes in it. So yeah, I had mine, all right, even though that's a starch, but what that is, it's a chain of glucose molecules. So as my body breaks that down, I'm getting glucose, 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 oh, glucose. All right, so if I'm thinking about the cell of my body, all right, and I know that I've eaten something that's given me a glucose, once my body gets that little tiny molecule, all right, that molecule gets to go directly into the cell, all right? If that cell is needing that energy, that glucose molecule can enter. If it doesn't, then it can go and be stored